Nathan, did you know that friction provides the force needed for a car to travel around a flat, circular racetrack?
Well, obviously, but do you know what the maximum speed at which a car can safely travel if the radius of the track is 80 meters and the coefficient of friction is 0.4?
Well, in this case, I don't really know what to do here, but I think using physics, we can probably solve this.
Physics can solve anything, so let's get to it. So, first, I think we need to find the circumference of the track. Because we need the distance in which this car's traveling around.
Well, it's funny you should say that because my first thought was that we needed the circumference, but I don't think in this scenario we actually need to find the distance of the track. I think all we need is the coefficient of friction and the radius.
Well, I think that would mean we use equation 9 sub equation 1.
And what exactly would that be?
That'd be mu equals a of c over little g.
Because centripetal acceleration over the acceleration due to gravity?
Well, naturally. So let's just run some numbers here.
So I recall you saying that the coefficient of friction was 0.40. Was that correct?
Of course, Nathan.
Okay.
So always remember, kids, don't forget to restate the equation you're using, because you can lose points for that. Okay. So remember, we're using equation number 9 sub equation 1. So mu equals a of c over little g.
Mm-hmm.
So we know mu is 0.40 equals a of c over 9.81 meters per second squared, of course.
Which is the acceleration due to gravity.
Well, naturally. And you never want to forget your units.
Meters per second squared.
Of course.
Which is how you define acceleration.
Exactly. So using this, we can solve for a of c by multiplying the denominator of that fraction by the mu value.
Of course.
I think off the top of my head, that'd be about 3.92 meters per second, I'd say.
3.92 meters per second?
Yeah.
Okay. So, I see. Well, squared, of course, because we're finding the acceleration.
Well, Nathan, I think you're mistaken. We are not finding acceleration. We are finding velocity.
But the value of centripetal acceleration has to be squared because it's acceleration.
Well, naturally.
But here you're onto something. I see what you mean. Now that we know the acceleration, we can look for the velocity. I think we're going to need equation number 18, which is centripetal acceleration equals v2 over radius.
All right, so let's just throw on equation number 18. A of c equals v squared over r. So we know a of c equals 3.92 meters per second squared equals velocity, which let's just say x because we don't know it, squared,
yes,
over the radius, which is 80 meters.
Mm-hmm.
So as you know, we can just multiply those values, and off the top of my head, I think that'd be about 313.9 equals x squared.
So what you're saying is v squared is equivalent to 313.92?
Well, rounding, of course.
Rounding.
So it'd be 0.9. But you're on the right track. So now all we have to do is square root both sides.
All right.
So do you know what the square root of 313.9 is?
17.7 meters per second?
So looks like our velocity is 17.7 meters per second, which means that the maximum speed at which a car can safely travel if the radius of the track is 80 meters and the coefficient of friction is 0.40 would be 17.7 meters per second.
Thanks, physics.
I love physics. We'll be back soon.